am tearing up.
I just about screamed right now, and I'm not even there.
Now that's inspirational, Natalie. I feel inspired today.
Are you kidding? I could be here for another hour.
And I was the top of my class. There were only 2 of us, and the other guy was in the hospital. So here I am.
And I always go, he winds up homeless on the street. It's my fault.
Yeah, now you sound like my wife.
And you can get off.
I don't know. We call it Google or call it Google. Call the Border Patrol.
Alexa, how does he get across?
Paul, I cut you off earlier. What were you going to say?
What?
Dang it! Don't do that to me, Paul. Don't do that to me, man.
I don't know what got into my head, but I thought this thought, if I'm working year round, I might as well get paid year round.
Sweet Talk is a weekly 20-minute podcast brought to you by the Continuing Education and Workforce Training Division of Idaho State University's College of Technology. Find us on Apple Podcasts, Spotify, and SoundCloud, and subscribe today. Now, it's time to get started with Sweet Talk.
Hello, everyone. Welcome back to Sweet Talk, our weekly podcast here at Idaho State University's Continuing Education and Workforce Training. I am, as always, one of your co-hosts, Paul Dickey, the Video Instruction Manager and Apprenticeship Coordinator here at SWEET. And as always, I am joined by my other co-host, Gary Salazar, the Director here at SWEET, Continuing Education and Workforce Training. Gary, how are you doing today?
I am doing great, Paul. Thank you very much. I love your approaches on this. Hey, it's a great day. We got a great guest coming up, and we also have Angela. Angela, who's our marketing coordinator with us, another co-host. There's co-hosts coming out all over the place. We got to do a rap song. Yeah, this is awesome. It's good to see
you're
you.
fixated on that rap there. You're fixated
Well,
on
you
that
started the thing with rap.
rap.
Hey, cool. Thank you for getting us started, Paul.
Yeah, you're welcome. So, Gary, people may not know about this is I think our second podcast after the break, the holiday break. I was not here for the other podcast that you had. Just glad to be here on a brand new year. Really excited.
You're right. Thanks for bringing that up. And I had to make excuses for you last time. I almost forgot, but Angela got us cued in. We had a great podcast, and coming into number 2 this year, we're going to have another wonderful podcast with a very interesting program coordinator. And anybody who ever wants to know anything and everything about robotics, this is the podcast place to be. What do you think, Angela?
I can tell you I am so excited to have Shane as our guest today. I don't really know anything about robotics, so this is going to be very new to me.
Absolutely, for me too. We have joining us today is Shane Slack. Shane Slack is the robotics coordinator for the robotics program here in the College of Technology, and he is been gracious enough to come on, and I'm excited to talk to him also because I think robots are amazing in what they do, and he gets to work with some amazing young students who've got great ideas and plans. So welcome, Shane. Thank you for coming on board to Sweet Talk. How are you today?
Good. Thanks for having me.
Hey, glad to. Hey, the audience probably doesn't know a lot about you. Would you take a moment and just kind of talk a little bit about your background and what you do there?
Sure. So like you said, I'm the program coordinator. I started out back in the 80s in high school, kind of fell into electronics with my friend's dad. He had a little computer shop here in town, and we were building PCs. PCs were kind of a brand new thing back then.
Yeah.
We were putting those together. We got started into the video production realm. So we were building video production PCs for people in the area. We built the first ones that Channel 8 had, that Channel 6 had locally.
Oh, wow.
We even did some stuff for Mountain Home Air Force Base so that they could do their own video production stuff. From that, I got into semiconductors just as I need another job, make some extra money, as a kid.
Yeah.
And I got to work with some guys that were super smart. And the more I worked with them, the more they'd kind of teach me, some of the things that I was missing in electronics. And they talked me into taking a look at this, what was called the Electronic Systems program back then, 3-year electronics program here at ISU. And I kind of fell in love with it. I got into it, and I haven't looked back. Graduated from the program, went out to work again in semiconductors, and everybody knows how semiconductors are. If you've lived around a plant like we do here, with what was then AMI, then On Semiconductor, now LA Semiconductor, they're cyclical, so they lay off a lot when business goes down. And so I was looking for a change, and one of my instructors called me up one day and said, "Hey, we need some help here." And I told him I'd come back and teach for 1 year. That was in 1999, and I am still stuck here. So
1999 till now. Wow. You moved
Um,
around, and that's quite a career. So you are a clinical instructor here in the program as well,
yes,
correct?
yes.
Super. What a great bio to be able to say how you started out, and with a company that's physically still here,
Yep.
still doing great things in the semiconductor business, and now you're teaching that, using in something that we call robotics today. Were you thinking about robotics back in high school when you started getting this?
Robotics was something that you really kind of saw in the movies. Back then there was some little kits, but they were clunky. And if it was something that was really functional, it was nothing that you could really afford, especially in this area. So when I came back to teach, we were always trying to bridge that gap between electronics and what was then called mechatronics, and get more of that into the program, get more of the physical interaction in. And then one day, these devices called 3D printers came out, and it totally revolutionized what we were able to do. So we could build anything we wanted extremely cheap. We didn't have to go to the machine shop. We didn't have to, send parts out. We could build everything right here.
Wow.
When you're talking about building stuff, you're talking about building like electronic components that would become part of a robot?
That's a pretty good question. So our students, once they get through like the first year, they will build these circuit boards. They will build, they don't necessarily build like motors and things like that, but they will hand select motors and individual components, and then they will make sometimes plastic, sometimes wood prototype, and then all the way up to actual metal parts that will interface the electronics and the motors and whatever wheels and chains and things we need. So we basically go through the entire process, building from the ground up.
Wow. So Shane, in your program, is it kind of a set program where they're building the same robots each year in the program, or do the students get a chance to design a robot for a specific task, or is it a combination?
So in the first year, they're pretty much doing the same experiments. They're just familiarizing themselves with the parts. There are some areas, if they're doing really well in lab, if they're ahead, then they can design some little things. They're given some basic tasks that kind of meets the goals of that class. But yeah, some of them do end up building some little things throughout. But then when they get into their capstone project in the final couple semesters, the things that we do vary. We have a couple projects we work on with the police department. We have some that are entrepreneurs that bring in ideas for our students. So it's really varied. It's extremely varied. Right now we're doing one with the occupational therapy program. One of their students, they kicked off some ideas for their students. Hey, come up with something. And some of them came up with this idea of a wheelchair that could help somebody with limited mobility. They may have a tough time actually moving an electric wheelchair. They may crash into people, something to correct them and help them keep it on track, keep it on the sidewalk. And so right now we're in development with that project, just trying to interface any standard wheelchair to our circuitry that can just assist in driving, eventually offer maybe training levels for those people that could develop those skills to be better, or just, overall correction for people that are just have a difficult time with it.
Wow.
So yeah, everything is different.
I have a question. I'm extremely unfamiliar with the robotics program at ISU in general. Can you explain to me and anyone else in our audience listening what the robotics program is, like what types of jobs that you prepare the students for?
That is that's a wide-based question. So the program itself, we are electronics based. What we do here has been here since 1941 as an electronics program. And we've just continued to evolve and, try and keep up with what's happening out in the real world. So for me to say robotics, we do basically everything that's inside the robot, all the electronics, sensors that go on it, drive systems. We try and teach pieces of that. Even wireless communications is an entire semester that we teach the students. We have summer lasers. So if students, it's an optional class, if they're interested in how lasers work, and how they can apply that to what they're doing, whether it's through fiber optics or through other types of sensors, we have a class for that. A traditional robotics program that we see is somebody learning how to build or how to program something that's just taken off the shelf. Here's a FANUC robot. It's an industry standard. You learn how to program it. We don't do that with robots. We expect them to design the robot for their task. If it might be a piece of something that's an attachment, or it could be the entire robot chassis. But in some way, they are doing the development based on a need that they're trying to meet.
Oh, that's good. I'm glad you mentioned that because I was thinking, where's the programming piece in this? Because how do robots know what to do? Yeah, and that's a little bit different element from what you're doing.
So when we talk about programming, we're not looking at taking, something for a specific robot. The students basically build their own microcontroller, little mini computers that controls the robot or part of the robot. And there may be 15 circuit boards, each of them with a processor that controls a different portion, and then they have to make them all communicate. But they do all of the programming no matter. So we teach 5 programming languages throughout the course of the semester that integrates in what they're doing. So some of them, not all of them are for specifically like a mobile robot. We do lab simulation software. So if they want to go to work in INL and do development out there, they're familiar with that.
So you're teaching them a whole bunch of skill sets and building these robots. They're learning electronics. They're learning how to manufacture or machine and build these things, and also they're learning how to program them for the tasks that they want them to do. That's kind of, that's, to me, I'm just a layman. That seems almost overwhelming to get that much. What's the length of the program?
So we are 3 years for the associate degree, and that's what we have an extra year compared to everybody else. That's why we're able to fit so much in. We do have a bachelor's degree. So for the 4-year degree, depending on the amount of gen eds that the students have taken before they get to us, it could be a pretty quick final year, or it could take them usually about 1.5 years to finish up. So,
wow.
So it's a 4-year program. I'm trying to wrap my head around this. It's a little bit different than what I thought. So thank you. When you mentioned that you're teaching programming languages, is that like, Fortran, COBOL, C++, or is this something else when you talk about languages?
Yeah, similar to that. So we do Visual Basic, Visual Studio, which, there's several other languages that can integrate with Visual Studio. LabVIEW is their first one that they do, and it's a drag and drop. It's meant to interface with equipment.
Okay, so is it the same type of language they would use for PLCs?
LabVIEW is actually very similar to PLCs, and it will interface with quite a few. So if you look at some of the nice Allen Bradley languages where you can visually see what's going on, LabVIEW is very similar to that. Yes.
Wow. Okay.
Yeah. Then we do 2 semesters of Visual Basic. And then the second semester, the advanced one, we get into embedded C. And so they kind of make that shift over. We also do assembly level language in the beginning of that semester when they're learning processors. It's basically other than doing the specific ones and zeros that the computer is reading, that's the next step up from fundamental computer language. So it allows us to be extremely efficient and very accurate in our timing, where if we do C, we are at the mercy of the compiler to decide how long it takes to do a process.
Sure.
Right.
What you're teaching at such a great level with participants, students who come and they want to learn this. For me, that's a fundamentals that they're learning, but it's a foundation they need for everything else. Where can somebody end up in robotics? I mean, we have robots or drones, or I don't know what you call them anymore, on Mars. They have to learn what you're teaching now in order to get there, right?
Yes. And so we have students that work with drones. We have students that work for military contractors, and they maintain those drones that get out and deployed and go, either go search for people or, doing disaster relief. And, not just the little hobby ones. These guys are doing the full Predator drones. They're maintaining all the systems on those.
Wow.
If they go out with the system, they'll go out with basically one of my graduates, a pilot and a mechanic. And those three guys, they run everything. They keep that thing in the air as long as they're out with it.
What a great career field for somebody. And it's probably, just continuing to grow with all the technology changes, advances that come on up. I mean, if anybody's interested in this at all, this sounds like a fantastic program to get into with you. And you've been here for 20, 25, 24
About
years
24
doing
years,
this.
yeah.
Right. Wow, Shane, you've seen so much since that time as it's grown on up, and
Yeah.
you look younger than when you started too. So congratulations on that. Yeah. Hey, we're getting close to the end of our program. I know it's gone by quickly here, but before we get too far down the road, if we had a student out there who was interested, wanted to ask more questions, I mean, do you have any recommendations on how they could reach back and either contact you or the program? What would you advise them to do?
So, we have a phone number for our department, 208-282-3851. That gets right into the department. They can contact student services at the College of Tech also and set up a tour. My email address is posted everywhere online. So if somebody just wants to shoot me an email, we can get them set up. The main thing is getting somebody in here to see, 20 minutes is not long enough to describe everything that our students do, everything they're capable of, the variations in jobs, power industry, power security, the things that we learn in programming and circuit analysis. It can take them anywhere.
Wow.
So robots it's a fun way to teach what we teach, but it's a small portion of the industry.
Wow.
So yeah, there's a lot to do. And
yeah, so I'm going to put you on the spot.
Okay.
And 24 years of doing this, and what's one of the coolest things you've ever seen in your class?
The coolest thing I've ever seen in the class, man, that changes all the time. So actually, I'll tell you, one of the coolest things that I saw that's one of the most memorable, we had a graduate that had been out, and I mean, he graduated a long time before I did. He came back to do a tour, and he was actually one of the guys that created the heads-up display for the Apache helicopters.
Oh, wow.
Oh, wow.
And so, him and another guy, they come up with this thing, and they made all kinds of money off of this. Just to know that, some of the things that these guys do when they leave, they don't just have to go to work for another company. They can start their own companies. I heard, and I haven't met him, but one of the guys, you guys are young enough to remember Teddy Ruxpin.
Oh yeah.
Right?
Oh yeah.
One of the guys, the guy that came up with that came through this program. So
really, wow.
So it's just these ideas that come off these kids' heads when they come in. And sometimes we take those into projects, and sometimes I say, you know what, that's a great idea, but you need to go down and talk to Jeff Street and let's get a patent on this thing before we do anything so that you own the idea.
Nice. Well, that's amazing. I've only walked past it in your department a couple of times, but you look in and you always see all your students with their heads down working on their projects, and they're so engrossed in what they're doing a lot of times that they're completely focused on working on their projects. And your explanation of all the things that they learned, the manufacturing, the electronics, the coding, that's so much to absorb. I would imagine that you have some students that have really excelled and created some amazing stuff in your program, and if just given the opportunity.
Yeah. And if you have the ideas, if you have the tools, and you have the drive to get something done, it's amazing what somebody can accomplish even in a short period of time. And
Mm.
really, that's what we're doing. We're supplying the tools, we're supplying support, and we get these kids in that they want to do it. And wow, great ideas. Let's build something. The first time we built an R2D2 was, a student saying, "Hey, I've loved this movie. Can we do it?" Well, yeah, let's do it.
That's so, yeah, and I've seen that. It's really cool. Like, it's really cool.
What's really, really fun to hear you say, Shane, is, hey, let's try that. If somebody comes with an idea, there's no, we can't do it. Let's go find out, and
Right.
even failure is a great teacher, but just the chance to join a program that allows that kind of, dream about it, check it out, go try it out. I mean, there's so many successful companies in our country who have that entrepreneurial sense, but here we're finding it in the classroom. Congratulations. I mean, well done with that. What an amazing program. It literally, what's the name of that, the guys who did that plane? Oh, the Skunk Works, the Skunk Works who developed all these amazing ideas on the sly for a while, and then out come these amazing planes and whoever knows what else, but what a great thing to be doing. You've done a great job with that for 24 years. Congratulations. And
Thanks.
it's so nice to have you come on board and talk about that. You may have heard that our timer went off. So we are at the end of our 20 minutes. And I have a few other questions, but we just probably need to wrap this up and let people who might be interested to come find you and talk to you. I'm really excited that you did come on and talk to us about this, Shane. If we go ahead and close this up, is there one last thing you'd like to say to anybody out there about what you do in the robotics field?
So what I'll say is, even if you're not sure what you want to do with your life, the things that we teach, they're so varied, and it offers up so many opportunities in different areas of robotics and electronics that you may go through a program and you're stuck in something, but here you have so many things to try out. Odds are, if you like working with your hands, you're going to find something that you absolutely love in this building. So come try it out, see what's out there. And it's always worth your time to investigate something that's going to open doors in the future, I think.
Yeah, absolutely. You can say that again.
Nice.
Hey, Angela and Paul, we've reached the end of another podcast, and it was a really good one, man. We're gonna have to close this thing up. Hope you guys are ready to do that.
Yes. You know me. That's my job.
You're gonna put the wrap on it, aren't you?
Yeah, I'm gonna put the wrap on it. See, Shane, that wrap thing's coming back. All right. So if anyone wants to contact us here at Continuing Education Workforce Training, you can email us at cetrain@isu.edu. You can visit our website to see what we have available for classes at cetrain.isu.edu. And you can give us a call at 208-282 3372. See, I've been gone for too long for the break, Gary. I kind of stumbled on that phone number at the end.
Get back into it.
This is a real professional podcast, Shane.
Well, even I forgot to mention something. This was Shane Slack. I mean, this is the guy who runs our robotics program. He's a coordinator, and thank you for coming on board.
Absolutely.
I'll let you go ahead and finish that up, man.
All right. Thank you all so much. Thank you, Shane, for joining us. Angie, as always, and Gary, I can't do this without you, man.
Hey, we're all in it together.
Okay.
Hey, you all be safe out there.